Welcome, ladies and gentlemen, to your part 2 video on solving your application questions with exponential and log functions. So if you remember from yesterday, we left off talking about law of cooling, Newton's law of cooling. And the key with this Newton's law of cooling and the second example that we're going to have as well is that the formulas are extremely long. Okay, so we have to make sure we copy down the formulas correctly each of these times. So in order to do that, you should all have your blue note sheet, that magical note sheet on your desk as you're filling in the rest of these notes. Okay, so if you read through this example, it says a frozen steak has a temperature of 28 degrees Fahrenheit. It is placed in a room with a constant temperature of 70 degrees Fahrenheit. After that 10 minutes, the temperature of the steak has risen to 35 degrees Fahrenheit. So what we're trying to do to start is find what the temperature of the steak was actually after 30 minutes. Before we can do anything like that, we need to make sure we find out what that constant value is, or we find out what that K value, or as we were referring to it yesterday, the R value, because we were working on rates. So we need to find out at what rate is that temperature either gaining or losing throughout the time it's actually sitting there. Okay, so look at some of the information that we have. The temperature at time for our initial starting point here would be 35. Okay. The surrounding temperature is how warm it is in the room. It's our 70 that we're actually dealing with. Our temperature at the time of 0, so initially when you received it, or I should say when it was frozen, would be 28 degrees. And last but not least, the time we're actually looking for originally that we were given is the 10 minutes. So all of this information is going to play in to getting that basic baseline formula for us. All right. So before we can even attempt anything with the example, let's fill in the information that we know. We have that 35 equals to our 70. And again, what we're looking at now is our Newton's law of cooling formula. Okay, so we have the initial temperature equals our 70, which was the room temperature, added with, and then we make sure we use that parentheses in there, our 28 minus, again, that room temperature. And we multiply that all with an E and then raise it to, and I'm just going to put K for the constant, doesn't matter what letter we use here, times our 10. So as you can see here, we have to do a little solving to make sure that we're all right with this. So first thing you do is subtract the 70 to both sides. So you end up with a negative 35 equals your negative 42 because of what's inside of the parentheses, e to the negative 10k. So again, before we can do anything with natural log, we need to do a little division to both sides. So we divide both by a negative 42. So we end up with a 0.83 repeating in this spot. That's equal to our e to the negative 10k. And now we can finally take that natural log of both sides. So we have natural log of our 0.83 repeating equal to a negative 10k. You divide both by a negative 10k, and you end up with your k value equal to a 0.018. I'm going to round it off just a little bit to make my answer shorter. Now that we know what the constant value is, we can use that constant value to actually figure out what A is asking for, what the temperature would be after 30 minutes. So now to solve for A, we know that we're going to use the constant from above, and we're trying to find what the temperature at that time is. So we're solving for T. It's a plug and chug question for us. We have a 70 minus that 42, and then we have our E raised to the negative 0.018 multiplied by that 30 minutes that we're dealing with. And as you're putting this into your calculator, hopefully you can take a second here, maybe pause the video to actually try it in your calculator, because you would find that this is a 45.5 degrees Fahrenheit that we wind up with for our final answer. Okay, so if you need to stop at any point now to write some of this down, feel free to do so, because I didn't answer B yet, and I need to have a little bit more room here. So I'm going to erase what I have. Erase all this. I'm going to keep that K value up there for the time being. And now I still need to use that to solve for my B, and B is asking for how long it will take the steak to thaw to 68 degrees. So now that's what we want it to end with. Okay, we still need to use all of our same initial starting information, but as you can probably see with this, we're trying to find time with this example, which means we have our variable in our exponent. So that means we're going to have to get everything away from the e so that we can use the natural log. So we subtract 70 from both sides, end up with a negative 2 equal to a negative 42, e to the negative 0.18t. We divide both by a negative 42, so now we end up with a 0.0476. That's equal to an e to the negative 0.018t. Take the natural log of both sides, so we have the natural log of that 0.0476. That's equal to our negative 0.018t. Divide both sides by that negative 0.018, and we finally end up with our answer of a 169.1 minutes. If you want to change that to hours, you most certainly can. It's 2 hours and 49 minutes. Okay, question number 1 done. Now we need to move on to the next. Okay, unfortunately, this hits home with me. Hey, I have a little debt on my credit card. It's only $12,000 though, so it's roughly 1 year of what I make teaching. So it says Mr. V owes $12,000 on his credit card. The annual interest rate is 9.99% compounded monthly. So before I even read what A is asking for, I want you to take a look at what the equation is on your blue sheet for debt payoff. It's long, but it's not hard. Okay, so when you're going through here, A is now asking how long will it take for me to pay off the credit card if I make a minimum payment of $100 a month. Okay, not the best idea. Only $100 isn't gonna really chunk out the 12,000 very much, but let's see how long it would take. Hopefully you have a guess as to what that would mean. So if we're going to copy down that formula, the amount of years that it takes is going to be what I'm going to be finding before the equal sign. And now if I fill everything else in on the numerator, I have the negative natural log. In the parentheses, I have a 1 minus. And now if you notice with the equation, the P, okay, that is the actual, well, how much you owe, the principal. So in this case, I have my 12,000 multiplied, and now it's the next thing is the rate. Rate always is percent. And now the key is you have a nice, wonderful percent here. We need to make sure we move that decimal place to make it into a number that we can put in our equation. So now we're multiplying that by a 0.0999. And then we have that all divided by, and if you look at the denominator in our numerator, okay, the N stands for the number of payments made. It says it's compounded monthly, so we have a 12 multiplied by that minimum payment, which is 100. So that is everything in your numerator. I would strongly recommend putting that into your calculator first, right now, so that you get an answer. And I'm going to write what the answer should be off to the left here. You should get roughly a 6.908 on the top. We need something to do the same thing for the bottom. The bottom is much easier. If you notice, we have the n times natural log. N was how many payments we're making. It's monthly, so it's 12. 12 natural log. And then inside of our parentheses in the bottom, we have that 1 plus, and then a 0.0999. And now we divide it by, again, how many times we pay throughout the course of the year. That bottom number should be a 0.099. Or ultimately what we get for our final answer is it's going to take me roughly 69.4 years to pay off a $12,000 credit card bill if I'm only going to put 100 down each month. All right. For the second one, it says how long will it take if it's tripled the amount. So now all of a sudden the only thing different is I need to put a 300 every place I see a 100. All right. That's the only thing that changes here whatsoever. So if you do that, okay, if you write this all out again, I have my t. I have in that top a negative natural log. I have a 1 minus. In the top, I have that 12,000 times my 0.0999, all divided by my 12 times my now 300 in that spot. Okay, if I divide this Okay, I'll give you what that answer is to the top in a second. I have my 12 natural log of a 1 plus 0.0999 all divided by 12 here as well. When I put those in my calculator, I wind up with a 0.405 all divided by a 0.099, or this one would only take me 4.07 years. Okay, so look at what a couple $100 extra a month will do when you have a little bit of credit card debt. All right, hopefully after today you still enjoyed these application problems and you were able to see with one of my real life examples, kind of, how easy it is if you understand the parts of the formula. All right, now you will be able to work on the worksheet and we will go over any questions and continue to work on the worksheet Friday in class. It is not due Friday. You will have time to work on it Friday as well. All right, have a great rest of your day.